Right, hi, and welcome back. So this video is going to be talking a little bit about the robot design sheet that I used while designing uh, TSINC01. Um, that's the winning robot from the Inspire NC Catathon on in July. Now, what this is it's actually a derived sheet from Spectrum's utterly fantastic robot design sheet. You can find this on their website. It is just thank you, Spectrum. Thank you, Gregory. Like all of the resources you guys put out there are utterly fantastic, and it's super useful um, for me, for other teams, and everything like that. Now, this is basically the whatever second-ish robot that I've designed using this to organize all my information about it. And I don't think like the next robot 2220 designs is going to use this thing because it is so useful to have that information. Um, Maybe a little bit less useful for me because I have so much stuff like in my head memorized, but like I mean, even then, like like there's just dimensions that I don't have memorized that are in this that are just great. So this is going to be a tour over how I used it for this and some of the great features of it. Um, so first, a little bit of a tour. So I've moved some things around on here from what you'd get if you just copied it. Um, that was basically because I was designing this for a catathon robot. So stuff like checklists. Yeah, I don't actually compete with this, so I don't really care about that. Bomb, that doesn't exist anyways. Driver controls, I don't care. Status lights, I'm not going to be troubleshooting this robot. Electrical, I also don't really care because this isn't going to be actually built. Um, all things extremely useful for a real robot. Like this is a great troubleshooting guide. Like this is just useful. Like I wish that I had known about this when we were running into some troubleshooting that we're doing this last year. Like it's great. Um, this is great communication tools, driver controls, like stuff that you absolutely want to write down somewhere and keep updated so that people have that stuff. Checklists. You should be doing checklists. Like a lot of this stuff is just, it's nice to have this in one place. Part of the reason we moved there. Electrical stuff. This is great documentation for this. Highly recommended. You want to keep this information somewhere. Keeping it with all the rest of your robot information is a great idea. Um, So now that we've gotten through some of the stuff that um, I moved over here, we also have one part of this, which is just a bunch of reference charts. So um, dimensions on gears, drill sizes, Allen wrench it, and whatever Allen wrench sizes, like um, values for motors, identifying guides. Like this is great. Like that's it's hard to know what motors are right when you're just starting out, what motor is which when you're just starting out. Uh, Volt sizes also great, like great reference material here, all in one place. Gas shocks, something really nice to use when you don't want to use a pneumatic actuator and you just want to go in one direction. And now we're kind of getting, oh, and then let's move pneumatics over here too. If I used pneumatics on this robot, I would have used this a lot. This is a great calculator. Like, I wish that I had this calculator the last time I was doing pneumatic stuff. This is just super useful. The way that you use this is so I say I want, let's say I want a 3/4 inch bore, 6-inch stroke. So our retracted length is going to be 1069 and our extended length is going to be 16.69. Kind of the pattern for this is going to be anything that's purple is something you can change, like the box is purple. Anything where the text is purple is something that's calculated. Um, so super nice. Calculators, there's calculators here for like how much air you're using, which is great. variety of links to pneumatic components, also great. Like, I don't know, this is just awesome. Not sure what more to say there. I'll leave this bomb for. This bomb is just an imported bomb. So if I, where's select all, right? You can see this is the bomb. It's just the raw export from Onshape, which is nice. Now we get into kind of the meat, which is this calculator. This is just, it's probably overwhelming if if you don't know what everything is. You can kind of divide this into a few different sections. So there's stuff in here that's reference material. So gears, which gears actually exist? Like what gears can I buy and which ones can I use? So that's reference material. Reference material on motors is over here. There's some gear calculators if you don't want to do those calculations in CAD, if you want to just think about it. There's this nice will gear 1 and gear 4 hit, which is useful when you're designing compact transmissions. So you can think of this as mesh pairs. So 0 to 1, 2, 3, 4, and 5. Yeah, like I'm not going to talk too much about that. I didn't actually use that, so that what sprockets and chains are available, what belts and pulleys are available. I would actually ignore all these belts things because you can get basically literally almost any size belt you can get on V-belt guys or poly belt. Like, so I would never feel, and you can get it cheaper than you can get it from Vexpro. I love Vexpro; they have great products, but their belts are really expensive compared to what you can get off V-belt guys. So these guys, belt calculators. I would not recommend any of these belt calculators. So let's go through these because I want to talk about why I wouldn't recommend any of these. So I love West Coast products. I don't like their belt calculator. The reason I don't like their belt calculator is also the reason that I don't like the SDPSI belt calculator, which is that it restricts you to pulleys and belts that they sell. So, well, specifically in this case, belts, right? So you can see I would be fine with a 25 tooth belt, right? But it's going to recommend me only belts that Vexpro or West Coast Product sells, which is fair. They're a business; they want to sell their products. I understand that, but I don't buy belts from them, so like I don't care what they sell, what they don't. So I never use West Coast Products belt calculator anymore. Similarly, I don't like the BB manufacturing one because it does the same thing except for with just like everything. Like, hey, sorry, I have more belts. I have more pulley options than this. I can print pulleys. I can print whatever size pulley I have. So, not really useful for that reason too. So Design IQ. I actually have never used Design IQ. I thought this was like that. This might be useful. I haven't actually used this one. Ignore that for a second. This is what I use the most. It's this Technobots online one. I'll put it in the video description. The reason that I like this one is because I can just say I want a 233 tooth belt, and this will not tell me that I'm wrong for that. That's great, like because I can buy belts that are weird sizes. And I sometimes want a whatever 250 tooth belt with a 300 tooth. Like I want a whatever 250 tooth pulley on a 300 tooth belt. Like that's something that I might want for like a turret or something. And it's impossible to do in a lot of different belt calculation software. So Technobots Online is my preferred one. When this built-in one that they have, because of course they do, Spectrum's awesome. When this doesn't work, so there are cases where this won't work. There's a lot of cases where, like, I mean, honestly, I'm working on kind of adapting this to exactly what 2020 would use. I would just get rid of these. Like, I don't care about these belt tooth spacings for those specific ones. Like, they just aren't useful. Um, at this point, it's pretty much I just want to, I'll do whatever tooth count I want, and then make sure that the belt guys has it. And like 9 times out of 10, they do. Um, like I ran into a single belt size that the belt guys didn't have designing this robot. So where this usually breaks down is when you get small. Is pretty much where this breaks down, where you might need a different one. They also got a 3mm one, which is great, super useful. This is like a compressed version of JVN Calc. Like, if you aren't familiar with JVN Calc, it's like the granddaddy of motor calculation spreadsheets. Saves a ton of time. This is like a smaller version of that has all the different versions, the things that you would want from there, other than like sprint distance calculations, which you're probably going to be bouncing to a different spreadsheet anyways for, um, or bouncing over to like Jesse's drivetrain calculator spreadsheet. So this is great. Like, not much to say about it. So the way you use it is whatever you throw in, whatever motors you're going to use on your transmissions. Um, you say, I want whatever 10 to a 60 tooth gear. That's your overall ratio. I want wheel diameter 6 for, we can see what that looks like, 3, right? And how that switches up our feet per second. On an arm, you'll use your arm length and what the load is at the end of that arm. So that's great. So then we have a whole bunch of wheels here that are just useful references. Hardware, like this is a bunch more references too. Like, these references are great if you don't have these dimensions memorized. Highly recommended. There's some stuff that I've added here. So the main thing that I added here was, I don't see it now. Why don't I see it? I thought I had added tube connecting nuts. So I changed up the tube connecting nuts. Spectrum has one on there. I like will use basically anyone that works for ours. So I added that. And then I've added some more linked resources, the kinds of materials that we actually used. This is the kind of thing I would recommend doing this if you're adapting this for your team, is like Spectrum has stuff on here that's because they use it, it's on here. But if your team doesn't use that, you should take it off of there, because otherwise it's just going to confuse a new designer that thinks that you use 5mm plywood, but you don't. So let's take that over to like some examples of these calculations. So in this case, this is the elevator. So this is the like other part of this, which is how you use those. So you'll take elements off of that mechanical, and copy paste them over here to show your work on like an elevator. I'm missing some stuff here. Like, in a real thing, I'd probably be a little bit more rigorous about this when it's communicating with somebody other than just myself. We're actually going to build it. But you can see the calculations for this linear mechanism, which is what we'd actually be using here. You can see that our stall load is about 500 pounds, which is probably pretty good here. Yeah, like I did this as a single reduction, for simplicity. Like, this is a pretty good example on this robot of like where you might want to do some shifting on that elevator, just to get a really fast normal speed and then a slower but more powerful lift speed. So rotary mechanisms, didn't use that. Kept these gears over here just to calculate, um, just to remember what all exists there. Drivetrain simple, whatever, updating my transmissions. 3.25-inch wheels, you can see we end up like just south of 15 feet per second raw free speed. That's nice. Scrubber claw needed. So this is the intake bit of the scrubber claw. So you can see we get like this linear speed of like 26 feet per second, which is good, nice and fast, nice and zippy. Might slow that down if anything. Um, and then transmission here. That's for the rotation bit, which is nice. So you can see this rotation. We get like whatever 550 degrees per second no load times, but in 7 seconds. Like this is a super fast little arm there that would have no issues doing what it's doing. And then we have some. I liked to note some of the belt lengths here to make sure that we had those. And that's pretty much it for that. This is the template subsystem. So basically I made a copy of those for each of those mechanisms, and then I kind of petered out at the end. Parts list, something I didn't use. This is kind of my notes for scoring, so I kept those in here just to check my assumptions. It's nice to keep those all in one place. This is a note from before they changed the rules. So this is technically wrong. This is an important note for any climb, is whether you can react against the thing that you're climbing on. So the way that the climb was phrased this year is that you need to be supported by the tower of primarily you needed to contact the ring and be supported by the tower or something along those lines. So it was okay to be resting somewhat against the tower. Like you couldn't climb on the tower solely, but you needed to be, you could react against it, which is important in order to climb. Important dimensions, kind of some of those calculators. Mechanisms, constraints. Small is good. I ended up going with larger robot anyways. Flat field. Low bumpers. Low bumpers were important for this game for your roller intake, so notes there. We're kind of working my way through this backwards. Like this is kind of the initial stuff that I was thinking about. And then finally robot capabilities. This is how 2220 does ours roughly, is we have stuff that we need, stuff that we want, we have stuff that we hope we can do, and then we have stuff that we've just said we aren't going to do. So that's what that looks like. I hope this was a useful tour through the robot design sheet. I highly recommend doing it to keep all of your information in one place and make it easier to communicate among your team members. In addition to just like all the awesome reference material here for if you're just learning. Like there's just so much here that's dimensions and stuff that otherwise you need to go and look up in drawings, and that can really slow you down when you're just learning stuff. So thanks for watching. Have a good one, and see you next time.